We'll start today by looking at this particular pattern, figure 1. If you look closely at the pattern, you can see that it's got a certain number of boxes on the first row or along the bottom, and then it has a box that's stacked up on the right-hand side. If you move to figure 2, it changes in a certain way. Notice that now on the left we have a box stacked, and now on the right we have more boxes stacked as well. If I continue on to pattern or figure 3, maybe I can start to see a pattern. And in fact, one way that I look for patterns or show patterns when I'm looking at these is I start to color in what's new on figure 2 compared to figure 1. And so I just take a look at what I have. There are still 6 boxes along the bottom, but then in figure 2 it added this box on the left, and it also added 2 boxes on the right. So my adjusted pattern added 1 box on the left and 2 boxes on the right. If I look at figure 3, does it follow the same pattern? Well, it looks like yes. Figure 3 adds another box on the left and 2 more boxes on the right. And so if I ask you to draw figure 4, can somebody describe to me what figure 4 would look like? Yep, go ahead. So you're going to take figure 3 and add a new box on the left. So it'd be exactly figure 3, except for we would add 1 more box on the left and 2 more boxes tall. So I'm going to do my best drawing of figure 3. Figure 3 had sometimes they're a little bit difficult to draw, but it has 6 boxes along the bottom. So 1, 2, 3, 4, 5, and then 6. It had 2 stacked high up on the left, and it had 1, 2, 3, 4, 5 stacked on the right. So I'm going to draw 1, 2, 3, 4, 5 more on the right. And then like Nick said, that this was figure 3. Figure 4 is going to add another box and then 2 more boxes over here. Sometimes, like I said, I like to do it in different colors so that I can change the look of the figure in a very apparent fashion. But regardless of what color I do it in, figure 4 will still have 6 boxes on the bottom, and it turns out that it has 4 boxes high on the left and 2, 4, 6, 8 boxes high on the right. Figure 3 had 3 boxes high on the left and 1, 2, 3, 4, 5, 6 boxes high on the right. Figure 2 had, oops, that's a 3 here and a 6 here. Figure 2 had 2 boxes high on the left and 4 boxes high on the right. Are you starting to see a pattern? Figure 1 had 1 box high on the left and 2 boxes high on the right. Can anybody tell me, without actually drawing, how many boxes high on the left will figure 5 have? 5 high on the left. How about on the right? I heard somebody say something. 10, exactly. Notice that pattern. Figure 4 had 4 high on the left, 8 high on the right. That's 2 times 4. And then 1, 2, 3, 4 boxes in the middle of that. So let's do a quick figure 5 drawing. I need 5 boxes high on the left, 4 boxes in the middle. And then 10 boxes high on the other side. One, two, three, 4, 5, 6, 7, 8, 9, 10. So I did my figure 5, I think, correctly. I did 5 boxes high, 10 boxes high, and in this center, I kept that center at 4 boxes in the middle because I noticed all of them had 4 boxes in between the 2 side towers. So, knowing what happened or following those patterns, what if I had to go backwards to the figure that went before figure 1? And I'm going to call it figure 0. Can anybody guess what that might look like? Yeah, go ahead.
Is it just 5 squares at the bottom?
Does 5 squares at the bottom seem reasonable?
Or is it 4?
Or is it 4?
I don't know. 5,
Okay,
4.
one or the other?
Yeah, 4.
Which you're going with 4. I agree with you with 4. Yep, and that's a little bit tricky. Sometimes you kind of have to, it helps to go back and look at what's consistent. All of them had 4 in the middle, 4 in the middle. And so if I was going to figure 0, I would just have those 4 middle boxes. So figure 0. We're going to talk a lot about the figure numbers, but we're also going to take those figure numbers and we're going to put the pattern into a table. We made tables in the last chapter. We're going to put them together in this chapter as well. And so I'm going to look at figure 0 and count the boxes. 1, 2, 3, 4. We decided that there were 4 boxes in figure 0. Great. Now I'll go to figure 1 and do the same thing. How many boxes in figure 1? Well, the 4 initial, and then 1 on the left and 2 more on the right. So that gives me a total of how many? 7. Beautiful. How about 2? The 4 in the middle, and then the ones from 1, and then 3 more on that. 10. Excellent. In fact, in the table, we could go pretty quick here. Instead of counting them all, because that can get putsy, how many does it look like we're adding each time? Yep. So my next one would be 13. My next one would be 16. My next one would be 19. Perfect. All right, making a table is great for these small ones because I could even go back and count them if I wanted to. Finding the pattern helped as well. But I'm telling you right now, if I needed to find the 100th shape, I do not want to continue this table up to 100. Do you? Plus 3, plus 3, plus 3, plus 3. That would get very putsy. So let's go back to describing the towers. How many tiles would the 100th shape have on the left? Looking at our sample, figure 4 had 4 on the left, 8 on the right, and then 4 down in the middle here. So the 100th would have how many on the left? The 5th figure had 5 on the left, 10 on the right, 4 on the bottom. The 3rd figure had 3 on the left, 6 on the right. Again, how many would the 100th shape have? 100 on the left. How many on the right? $200 on the right. Beautiful. How many in the middle? And the 4 in the middle. What am I going to do with all those? Much easier than drawing the shape or making the table. I can just add the pattern that I have here together. 100 plus 200 plus 4 gives me 304 tiles. The point of this is to look for different ways to represent your patterns. We can represent them in the drawings. We can represent our patterns using the table. We can represent our patterns using a description. And in fact, we can even replace the actual number term with a really general term. In the left tower, how did the tower compare to the shape number? The number in the left tower is what compared to the shape number? Equal. So if I have X, the X shape, I would have in the left tower X squares. X just meaning in general. Like, what if I put 10 in here? Then I'd have 10 squares on the left. What if I put 20 in here? Then I'd have 20 squares on the left. How many squares in the right tower? So on my right tower, in the 100th one, I had 200. In the 5th one, I had 10. In the 2nd one, I had 4. Yep. 2x, beautifully said. I like that. In the right tower, 2 times x. And then all of them shared what? 4 at the end. So we could rewrite this as well as a simplified equation. We could clean that up, x plus 2x plus 4. So we could get the equation for our tile pattern by, like I said, adding those up. What is 1x plus 2x?
3x.
Beautiful. 3x plus 4. This is the equation for my tile pattern. It also asked us here, what do the towers look like? Well, we could just describe that as x on the left, 2x on the right. I know I forgot my E. And 4 in the middle. That's what do the towers look like? That would be my description. Giving a description is also important, so I want to go back up to here. Can anybody describe the pattern? What's happening each time? We already put that in our table. What's happening each time? My pattern is adding 3 tiles. So again, I can make pictures. I can describe, I can make a table, and I can come up with a general rule. And we're going to be doing all of that when we work with our lines and our sequences. So now, can anybody tell me something that they notice about our equation? We talked about a couple of different things. What does the 3 in front have to do with our tile pattern? Liberty.
It's the rate of increase.
It's the rate of increase. The 3 is the increase amount. What did the 4 have to do with anything? It's the figure 0 initial amount. So the 4 is the initial amount. When it comes to our linear patterns, that increase or rate, Liberty used that word, that rate of change is going to become very important, and the initial starting amount is also going to be very important. Okay, so now let's take a look at our next pattern. looking at our next pattern, I highly recommend that you try and find the change. So try and keep, in fact, if I look at my initial pattern, I keep that in the original problem, and then what's the change part in my new figure? Looks to me like I added this bottom piece. If I follow along to the next one, does that pattern seem to hold? Yeah, it sure does. I could pick up figure 2 and put it on top of figure 3, and then the only thing that I would need to add is those additional on the bottom. So I want you guys to do your best rendition, I'll give you a moment to draw, of figure 4 and figure 5. These get a little bit funny to draw, so I need to make sure that I have a little bit of room up on top here. Do my best to try and do my shape. So there was my figure 1, and then figure 2 added to the bottom and one diagonally over. This line is not supposed to be there. In fact, I'm going to get my white out and make that go away like it never happened, like magic. Okay, so that was now figure 2. Figure 3 added one underneath and one diagonal, and now figure 4 will add one underneath and one diagonal. Does this look like your figure 4?
No.
Oops. Does that look right? Yeah. Okay. So then figure 5, let's start the same way. I start with the original. Then I go to figure 2. Then I go to figure 3. Then I go to figure 4. Then I go to figure 5. I do not want to do figure 6, but I can go back and take a look at the change each time. What's the pattern? Pattern is how many extra blocks each time? Plus 2. So let's fill out our table. I don't have a figure 0 yet, but I can figure it out. Let's start here though. How many blocks in figure 1? 5. We already said we're adding 2 blocks each time, so how many in 2? 7. How many in 3? How many in 4? 5. Excellent. Whoa, let's go back. What would have come before 5? 3. So now let's go ahead and write the equation. Let's refresh. I want to look back at this. I'm going to sum this up. It went change times x plus initial, which is, I call figure 0. Okay? So change times x plus the initial figure 0. So in this case it is add 2 blocks, 2x plus the initial 3. We just wrote a linear equation by looking at the pattern. And in fact, when we get into our lines in our slope, we'll write this as y equals 2x plus 3. and then we'll make the connection between the slope and the initial figure. So if I want to use my equation, use my pattern to find the 20th shape, 20 goes in for which of these two letters? Which one represents the input? X. So 20 goes in for X. If I wanted to do it for 100 shapes, I would put 100 in for the input. Let's do it. How many tiles in the 20th shape? It would be 2 times 20 plus 3. 2 times 20 plus 3 is 43 tiles. That's in the 20th. How about in the 100th? 2 times 100 plus 3. What'd you get? 203. Beautiful job. When the input is 100, the output is 203. That kind of came from our last chapter material. So we're still going to talk about our input and our output. Yes?
Are we ever going to use this in real life?
That's always an interesting question that people ask. When are we going to use this in real life? Well, what we're doing here, finding the patterns, is yes, going to be used in real life in a lot of ways, but maybe not in this particular style. This is just to get us to our next spot. But yes, there are actually jobs that look for patterns. Computer programmers do it. If you work in finances, you do it. It's just at a different level, okay? So on our next spot, here we go. The equation is now given, not the patterns, not the pictures, not the figures. But we'll go back to figures. We'll draw them. Why? Because I like to. So I think it's fun. But here's the equation. What does the 5 tell me? The change. Yep. What does the 2 tell me? The initial value. Where does it start? So how many tiles in this sequence, or is this sequence growing by in each figure? What's it growing by? The change. That's the 5. What's the initial? The initial is figure 0. That's the 2. Knowing that, can I make a table? Yeah, pretty easily, right? Because my figure 0 is my initial, so my figure 0 is 2 tiles, and it's changing by 5. 2 plus 5 is 7, plus 5 is 12, plus 5 is 17, plus 5 is 22, plus 5 is 27. Nice job. So, does the table support part A? Did we start at 2 and add 5? It sure does. Another way I could check to see if my table supports part A is I could just do a test point. Is 5 times 3 plus 2, that's the equation, equal to 17? Yep, 15 plus 2 equals 17. That checks. It sure does. So we know we're in good shape. Does our table support figure 0 as well? It sure does. If I do 5 times 0 plus 2, do I get 2? 0 plus 2 is 2. That checks out as well. So I know it works because the numbers in my table match my description, and they match the original equation for the xth term. That's hard to say. Xth term. Speaking of xth term, I would like for you guys to try and find the equation. What do you need to find the equation? You need to figure out the change, and you need to figure out figure 0. So I want you guys, I'm going to give you a few moments to do that. See if you can figure it out. Did anybody find the change? Yep, Liberty. Perfect. 4. If you look at the original, notice that the next one added 4. Take figure 2, and it changes in figure 3 by adding 4. How about figure 0 if I could go back? If I could take away the 4. How many boxes would I have? Just 1. So I would start at 1. What does my equation look like? Y, beautiful, y equals 4x plus 1. And again, this is the real important part of what we need to get out of this. We want to look for the change. We want to look for the start, the initial value. So let's see if we can do it in the next table too. I need the change, and I need figure 0. I'll give you again a few moments to do that, and then we'll talk. Did anybody find the change? Plus 7. How about figure 0? What if I had to go back? Ooh, that's tricky. -1. Beautiful. Yeah. How can you draw a figure with -1 tiles in it? You can't really. But maybe if we had to, we would just draw a box and put a negative sign in it or something. Okay? But you can't really draw a tile that's not there. But anyways, let's write our equation. Y equals, give me a shout out. What is it? 7x plus -1. I write that as 7x minus 1. All right, the last one is going to be the most difficult, but then when we're done with this, I'm going to give you some problems to try on your own out of your homework packet. But let's start. We've got a tile pattern with 4 tiles in figure 2 that grows by 1. So figure 1, figure 2, I'm going to do figure 2, and I'm just going to be real lazy. Here's my figure 2. 1, 2, 3, 4, 4. It grows by 1. How many would figure 1 have? 3. How many would figure 0 have? 2. So figure 0 has 2. It grows by, my change they gave me is 1. What does my equation look like? Careful. I sort of wrote it backwards here, but what goes first? 1x plus 2. Or better than that, I write it as x plus 2. Does that make sense? Figure 1 has 1 plus 2 tiles. Figure 2 has 2 plus 2 tiles, so that works pretty well. All right, so your homework is the tile patterns in your homework packet, and there are 7 of them that you need to work on, questions that you need to work on, and you need to do all of them today. So 1 through 7.